Let's discuss breaker coordination and available short-circuit current. The question arises whether we need to worry about breaker coordination at currents exceeding the available short-circuit current, assuming coordination is necessary in the first place. While it might seem intuitive that coordination isn't a concern above the available short-circuit current, several factors necessitate careful consideration. Fault currents can, in reality, exceed the calculated available short-circuit current. One primary reason is asymmetry. Fault currents often exhibit asymmetry, meaning they possess a direct current component that effectively increases the peak current. This asymmetry can elevate the actual fault current beyond what's initially anticipated. Another contributing factor is the existing load current. If the system is already carrying a substantial load current when a fault occurs, this load current will add to the fault current, potentially pushing it beyond the calculated available short-circuit current. Capacitive charging also plays a role. In situations involving switching off a capacitor, the stored energy can discharge and contribute to a higher fault current than initially calculated based solely on the available short-circuit current from the source. Arc flash events introduce another layer of complexity. While an arc flash can create a high impedance fault, thereby limiting the fault current to a value below the available short-circuit current, it's crucial to recognize that even this reduced fault current can still cause significant damage. Effective breaker coordination remains essential for mitigating arc flash hazards, regardless of whether the fault current exceeds the initial short-circuit calculation. If breaker coordination is established based on the worst-case fault scenario, this configuration generally proves sufficient for all other fault conditions. This is because the actual fault current, in any scenario, cannot exceed the defined worst-case fault current. Therefore, if the breakers are properly coordinated for the highest possible fault current, they will inherently be coordinated for lesser fault currents. Regarding why gear manufacturers don't universally offer readily available software tools to easily coordinate their products, it's important to note that many manufacturers do, in fact, provide such resources. These tools often take the form of coordination software or tables. These tools simplify the coordination process by allowing users to input system parameters such as voltage, impedance, and transformer characteristics. This software then assists in selecting appropriate protective devices, like circuit breakers and fuses, to ensure proper coordination within the electrical system. By using these tools, engineers can optimize the selectivity of protective devices, minimize system downtime, and enhance overall electrical system reliability.